Hey friends, we are looking at section 2.2, and what we're going to be talking about is writing small numbers. And I know we started some of this yesterday, but we didn't get through everything, so let's just take a look. Our vocabulary words are going to pretty much stay the same. We're still talking about standard notation, expanded notation, and also number and word notation. Let's get started. The first thing we could do is kind of a warm-up activity. Let's look at dividing numbers by 10. Have you ever noticed when you divide a number like, I don't know, let's use a color here. Let's say 20 divided by 10. I'm hoping all of you are shouting that the answer is 2. So in a way, the decimal place started here, but it moved one space to the left. Let's see if that pattern holds for all of these division problems. If I have $10 and I've got to split it up amongst 10 people, how much money would I have? Hopefully you guys realize that it's $1. Notice that decimal place. It moved from here to here. So it moved one space to the left when I divided by 10. If we continue with that thought pattern, when I divide this by 10, what do you expect I'm supposed to get? Here we have, this number would be read as 1/100th. What happens when I divide it by 10? The decimal place is there, and I move it over one space. So now that 0 is right here. Notice that we could put a 0 here, and it would make sense that if we're moving the decimal place one space to the left when we divide by 10, we're going to move the decimal place over here so that we now have 1,000. So we started off with 100th and now we've got 1,000. So 100 divided by 10 is 1,000. I'm going to let you guys finish this. Pause me now, finish it on your own, see what you get, and let's check our answers together. If you got the following answers, you're in good shape. Let me give you more of the screen here. If you got the following answers, you are in good shape. Let me make sure you can see the whole thing. Okay, I think that's all right. We had a discussion, a couple students had a discussion yesterday, and they really wanted the zeros here for the ones place to say that there's no holes, and here we would read this as 1/10. We would read this as, this is tenths, hundredths, thousandths, 1/10,000ths, and this would be 3/100ths, and this would be tenths, hundreds, thousands, 10,000s, 100,000s. So this is 1/100,000th. All right, now that we've talked about that a little bit, I'm going to ask you guys to move on to your classwork packet, and I'm going to ask you to do page 49, and we're going to look at it together in a moment. Right now we are looking at page 49. I'll show you that down here. This is page 49, and this is in your classwork packet, so make sure you have that out. And this is from lesson 2.2. So what we're going to do here is we're going to read and write small numbers. So your assignment right now is to do pages 49 and 50, and we're going to talk about the first example. So if you look here, it says a grain of salt is about, what would this number be? Can you read it? We read this as 4,000ths. Remember, this is the tenths, hundredths, thousandths place. So we read this as 4,000ths, and what we're doing is we're writing it out as 4,000ths of an inch long. So the number that we see here in standard form, we're going to write it out in word form. So right here we see a penny weighs about, what number is this? What would this place be? Tenths. All right, so 1/10 of an ounce. I'm going to ask you to finish up. See if you can get all of these correct. Pause me now, take a moment to try it, and then we'll look at the answers together. Okay, only watch this if you have already tried this first page, page 49. Let's take a look at the answers. If you haven't, pause it, and we can talk about it in a minute. All right, so let's take a look. I got thousands here. This is 35 thousandths. Remember, when we look at these numbers after the decimal, we're going to read this as we would a regular number, that's 35, but then we think about where it ends, right? What place does it end in? And it ends in the thousands place. And we can continue on with that. This number is 28, and it ends in the 10,000s place, right? Because this is the hundreds. I'm sorry, lied. I'm sorry. This is the tenths, hundreds, thousands, and this guy would be the 10,000. So that's where they got that from. Toenails on average grow, toenails, so awesome to talk about, on average grow at a rate of 7/10,000ths of a centimeter per day. It takes 0.005 or 5 thousandths of a second for smell to travel from the nose to the brain. And here, when we look at the 1, we see that it is in the hundredths place. So this is 1/100th. And then over here with number 7, we see that a flea weighs about Remember, we read this as a number, 17, whatever number that is, but then 17, what place does this 7 fall in? The last digit falls in the hundred thousands place. All right, and finally, a snowflake weighs about, I counted carefully, tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. So this is the 100 millionths of an ounce. All right, 400 millionths of an ounce. Now let's look at these try this problems. They seem really hard, right? About how many times heavier is a penny than a dollar bill? So let's go back to our information to answer this. So a penny is a certain weight and a dollar bill is a certain weight. And if I remember carefully, let me go back and check because I'm not sure if I remember. A dollar bill weighs 0.035 or 35 thousandths, and a penny weighs 0.1 or a tenth of an ounce. And we're talking about ounces in both cases, so we're comparing it to the same thing. So let's take a look at what we have is this, right? And now, you know, we could think about when you're trying to figure out how many times something is greater than something else, the obvious choice is division, but I don't know about you, but some of you might feel a little bit uncomfortable with dividing with decimals. So let's think of an alternate way that we can do this. We can actually figure out how many dollar bills would add up to about 1 penny, or the weight of 1 penny, right? So if I started off with this $1 bill and then I added another dollar bill to it, I would get, when I added it all together, about 7/100ths of an ounce. That's definitely not 1/10 of an ounce, but we're getting there. So what can I do? Let's add yet another dollar bill to this, right? So when I add, I'm actually alluding to some of the stuff. We need to line up our decimals. And I have a 5 here, 7, 8, 9, 10, 0 down here, carry your 1. Aha! This is pretty close to this guy. It's pretty close to 1/10 of an ounce. So now that I see that these are really close in value, I'm feeling comfortable to say, you know what, a dollar bill is about 1/3 of a penny, but they said how many times heavier is a penny? It's 3 times, a penny is 3 times heavier than a dollar. Does that make sense? So I'm going to write 3 times here. All right, so the next question is asking about the rate in which your fingernails and toenails grow. From my problem, from what we looked at together, we saw that the average rate of fingernails growth is this right here, about 28 10,000ths of a centimeter per day. And then the average rate that toenails grow would be 7 10,000ths of a centimeter per day. Let's go ahead and compare it like we did the last one. Okay, so as I look at the toenail growth of being 0.007 and the fingernail growth of being 0.0028, and just looking at the numbers, not even thinking about where they are, I feel like 7 and 28 are related. I'm thinking of a multiplication fact, which is 4 times 7. And I'm thinking maybe this might be 4 times, the rate of fingernail growth might be 4 times. So that's already what I'm thinking. But let's go ahead and use the strategy we used last time. So I'm going to add 0.0007 plus another 0.007. Let me add 4 of them just to see what happens. Just to see if it gets close to the value that I expect. When I add 4 sevens together, I get 28. 8 down there, carry my 2. And just as I suspected, I see that the rate that a fingernail grows is 4 times the rate that a toenail grows. Okay, enough about fingernails and toenails. Let's talk a little bit about more expanded notation, but specifically with small numbers in mind. So this handy chart at the top is really going to help us kind of remember how to do what we need to do. It doesn't only have the words, it also has the decimal value, like the decimal version of each particular word there. So what we'll do is we will look at each of the terms and we're going to honor the expanded method. So write each of the following numbers in expanded notation. Notice that 5 is a whole number. It's in the ones place. I multiply it by 1. Here, 9 is in the tenths place. I multiply it by a tenth. 6 is in the hundredths place. I multiply it by 100th. I'm going to do this one with you just so we can make sure that we're on the same page. You can pause me now and see if you get it, and then I'm going to give you some time to work on the rest on your own. So when I look at this number, I see that 8 is being multiplied not by 1, but we're in the tenths place, so I'm going to write 0.1. I also see that we have the number 4 being multiplied, well, in the hundredths place, so I'm going to multiply it by 100th. Then finally 7 is in the thousands place, and so I'm going to multiply it by 1,000th. And this is what I have. If you're still wondering about the argument or the discussion, I should say, around should you put a 0 in the front, I tend not to put a 0 in the front in the ones place, partly because it confuses me when I see this and then I see this. I get a little confused. So I like not to put the 0 in the front so I can see clearly what's going on. I get it. I know some people really like it. I know some textbooks and places really like it. If you want to do that, you can. But make sure you're putting your decimal place in the correct spot. Got me? All right. So go ahead and try the rest of these problems here on page 50, and this will be our last assignment, and then after this I'm going to tell you what your homework is and you can get started on it, okay? All right, let's talk in a few seconds or in a few minutes. Pause me and then I'll show you the answers. Thanks. Okay, so I've got my answers down. Let's go back and take a look. What we did here was we really just wrote it all out in expanded notation. I talked about earlier that I'm not going to put a 0 here just because it looks a little confusing to me, and I think it's a little clearer this way. So let me know if you got the same answers. I hope you did. This second one, we didn't talk about the example, but I hope that the example made sense to you. Here, this 5 is in the hundredths place. So this 5 represents 500ths, which we write as 0.05. This 5 here is in the 10,000ths place, so it represents 5 10,000ths, which we write as 0.0005. This 9 is in the hundredths place, so that's 900ths written this way. This 3 is in the 100,000ths place, and so we write it this way. And finally, this 2 is in the tenths place, so we can write it as 2/10. This next part is really cute to me. I like fractions and I like working with them. And I want you to read this number before you even look at this. When you read this number, you say 735 thousandths. And so we write exactly what we say. So when you know how to say a decimal, or how to say a decimal, you can write the fraction really easily. So 735 over 1,000 is 735 thousandths. 41, well, this is the whole number 3, so the whole number 3 is there. So this is a mixed number. So 3, let's deal with the decimal portion, 0.41. 41 hundredths, and we write it that way. And that's the way I filled out mine. I just kind of went through and said, well, this is 3 hundredths, and I wrote 3 hundredths next to the 17, 75 thousandths, and 543 10,000ths, and you see that 235 next to it. All right, over here, this kind of goes right back to what we talked about earlier when we were doing our division. If I have 1/10, it's equal to 1 divided by 10. So if I think about what 1/10 looks like, it looks like that. What do I have to divide 1 by in order to get the decimal to move back 1 space? I'm going to divide it by 10. Remember our example earlier? And over here, 1/100th. So if I have 1/100th, which looks like this, which looks like this, sorry about that. What am I going to, okay, this is cool. Sorry about that. I started looking at it really crazily. Okay, so 0.01, that's 1/100th. What do I have to divide 1/10 by in order to get 1/100th? Well, again, notice the decimal point just moves 1 space to the left. How do we get that to happen? We divide by 10. 1,000th, and we know that that looks like this. How do I get this number from this number? What do I have to divide this number 100th by in order to get 1,000th? That really just means moving that decimal place over 1 space, and that's going to be 10. And so we get that's equal to 0.01, or 100th divided by 10. Is that all right? I hope it's all right. Let me know. Be honest. If you're not getting it, if you need some help, turn around, ask a friend, ask the teacher in the room. You can hold your questions till you see me next, but you won't see me until Monday. So I don't think you want to wait till then. So I'm going to ask you to make sure you have your questions answered in class today, especially before you start the homework assignment. So I'm going to give you the homework assignment right now. So you're in good shape if you did all of the pages in your homework packet up to the Math Boxes lesson 2-2. So I want you to make sure you get Math Boxes lesson 2-2 done. That's on page 51, and you can stop there if you have done that. So if you've done all of that and you're good to go, everything up to lesson 2-2 Math Boxes, you're good in your homework packet. Get it done. Now, for those of you who have already gotten that done, let's go back to the star problem. We're talking about how many different distinct squares are in an 8x8 checkerboard square, and what you notice here is that we have 64, right? And then you've got one big one, so you say 65. But you got to look for other sizes. What about this 2x2? What about a 3x3? What about a 4 by 4? Let me use red. 4 by 4, 5 by 5, 6 by 6, 7 by 7. The little